Hello. My name is Camille Valchuk, and today I will present a brief summary of my special seminar presented at the Department of Physics at the Wright State University in Dayton, Ohio. This lecture took place on Friday afternoon, January 13, 2012, and the title of my talk was, After Inflation Cosmology Based on Newtonian Gravity. As pointed out by Albert Einstein, the eternal mystery of this world is its comprehensibility. Since the world around us appeared to be rational, we may ask ourselves a question: can we understand the origin, evolution, and fate of the whole universe in accordance with the laws of physics? Through ages, this question was addressed by philosophers and theologians, but rapid development of physical sciences in the last centuries brought it also to physics, giving birth to physical cosmology. The invention of telescope enabled observations of very distant celestial objects, enriching our knowledge about the structure of our universe and dynamics of its components. Bold and more general physical theories were applied to the largest and the only isolated system that we know, providing more and more coherent picture of how our universe works. Among four basic forces of nature, only the weakest gravity plays crucial role at cosmic scale and governs the evolution of our universe. Modern cosmology is based on Einstein's general relativity from 1916, which replaced its predecessor in describing gravity, Newton's force field theory from 1679. However, it is possible to derive all basic equations in modern cosmology, the celebrated Friedmann-Lemaitre equations, using Newtonian theory of gravity, while the obtained results are consistent with already known history of the after-inflation universe as well as recent observation of its accelerating expansion. To achieve full agreement with the relativistic results, we need to reinterpret the gravitational potential in terms of the curvature of spacetime. Here we can distinguish three different eras in the post-inflation evolution of the universe, dominated by radiation, up to 5,000 years after inflation, dominated by matter, up to 11 billion years after inflation, and dominated by dark energy, above 11 billion years after inflation. It should be noted, however, that the inflation process itself is still questionable among physicists. Presently, we already know that our universe burst into existence nearly 14 billion years ago as a result of quantum fluctuation expanded in size by the swelling process of space itself. This conclusion is an extrapolation of unchangeable laws of physics back in time to the deducible moment of the Big Bang in accordance with the rules of mathematical and logical reasoning. Presently, the universe is made of coexisted and coupled together, interacting, 37 or more fields, including spacetime continuum as a special form of gravitational field, while their local vibrations, localized packets of energy, or local excitations, are recorded by our devices as elementary particles. It should be noted, however, that the quantization of spacetime is still not fully accepted procedure in physics, while the existence of gravitons as hypothetical carriers of the gravitational field has never been experimentally confirmed to this day. Our universe is closed, has no boundaries, while its total energy is exactly equal to zero, and therefore our universe is also characterized by infinite lifetime, has beginning, but will never come to an end and therefore will last forever. The positive energy associated with matter and energy contained within our universe, including also their dark forms, is exactly compensated by the negative energy associated with the spacetime curvature and caused by the presence of all forms of matter and energy. The evolution of our universe is already quite well understood by scientists, while the evolutionary appearances of biological life and human consciousness are already less and less speculative. Physicists are also trying to figure out what are dark forms of matter and energy which actually constitute as much as 95% of our universe. The follow-up question arises: what is the ultimate fate of our universe? Despite all the mentioned unknowns, physicists and cosmologists already figured out how the universe will look like close to the end of its purposeless existence. Intergalactic gravitational attraction will combine together the neighboring galaxies into huge agglomerations of stars. For example, in about 4 billion years, our Milky Way galaxy, which contains nearly 300 billion stars, will collide with Andromeda Galaxy, which contains nearly 1 trillion stars, and merge into one enormously huge cluster of stars with a graceful name of Milkomeda. The accelerated expansion of our universe will result in the local clusters of stars moving away from each other with higher and higher speeds, gradually pushing them beyond the horizon. With the time passing by, our universe will become colder and colder as well as emptier and emptier, with observers' visibility limited to only one agglomeration of stars. The stars will gradually burn out their fuel, transforming themselves slowly into the dwarfish concentrations of heavy elements, super-dense neutron stars, and black holes. For example, in the center of our Milky Way galaxy, there is a black hole with a mass nearly 4 million that of the Sun, while in the center of Andromeda Galaxy, there is a black hole with a mass exceeding 100 million times the mass of the Sun. Black holes will gradually absorb all the matter in the universe, and then they will evaporate by emitting radiation into the empty space, as predicted by Stephen Hawking. Moreover, the collisions between black holes and neutron stars will generate the gravitational waves into empty space, the ripples in the spacetime continuum. After the evaporation of all black holes, our universe will be filled only with electromagnetic radiation, in the form of massless photons, and gravitational waves, which will gradually lose their energies due to the cosmological redshift process associated with expansion of space itself. At this stage, the universe will asymptotically go closer and closer to the temperature of absolute zero without any participation of matter. Gradually disappearing field vibrations will be present only in the electromagnetic field and the spacetime continuum. Since both electromagnetic and gravitational waves do not feel any passage of time, the concept of time as we know it will certainly become meaningless. Interestingly, the residual entropy of the whole universe will become smaller and smaller, asymptotically approaching zero. It means that our universe will become much simpler and more organized near its end than it is today. Finally, the ultimate fate of our universe is some kind of timeless dissolution into the state of vacuum, which we could also call dissolution into nothingness. However, this is not nothingness in the ontological sense, because the universe will actually continue its timeless existence in the form of extended quantum fields and the spacetime continuum in their lowest possible energy states, or unexcited ground states. Interestingly, our universe was sparked by quantum fluctuation and began its expansion due to dark energy in the cosmological event called the Big Bang, while ending its existence in the process of timeless dissolution into nothingness, or some kind of decay into unexcited vacuum state. And this is the end in the formal and informal sense. Thank you so much for listening. That was my presentation with a very superficial summary of the material presented during my seminar. Of course, the devil is in the details, and a thorough understanding of this topic requires mathematical formulation and lengthy derivations. Since the ultimate fate of our universe is timeless dissolution into nothingness, then the existence of any human being is also pointless. This statement is a very positive and powerful, because it gives everyone the freedom to decide for themselves, define their own purpose in life, and give meaning to their own existence. If you are interested in specific topics associated with physical cosmology and its philosophical implications, then please subscribe to my channel and hit the bell, so you can get notifications of some new material uploaded there. If you enjoyed this presentation, then please hit the like button to give me motivation to work on other presentations. Also, don't forget to leave your comments below. Is there any specific topic in cosmology that you would like to understand better? I would be happy to help and prepare another presentation on the topic suggested by you. Have a meaningful existence.